Hi there, you're in love with your mate JJ. Today is Maxitronix Day. We're going to work through the Maxitronix 30in1. We're up to project number 6. Today's silly job title is Switch Sleuth. Today I'm the Switch Sleuth. And we'll be sleuthing our way through the 6th project of the 30in1, which follows on from Circuit 5, which we did last week, which was an introduction to the transistor, the electronic trigger. And this week, we're going to go deeper with the transistor, and we're going to use it as an amplifier. And we're going to try amplifying a simple radio circuit. I always find that the radio circuits don't work out, but we'll build it and test it, and we'll see. So we'll jump over to the computer, and we'll have a look at the instructions and the schematic. Then we'll draw up the schematic in KiCad, just for the sake of it. I don't think really you can test it in KiCad. I don't know what facility KiCad has for like those ferrite aerial coil things. So I don't know how you test the radio circuit in KiCad. So we'll just draw it up for the sake of having the drawing, but not for the sake of the simulation. Then once that's done, we'll go over to the booth and we'll assemble the circuit, and then we'll bring it over to the bench and we'll have a look at it and see what we can see. We might even just feed signal generator into the amplifier and see if we can provide it a signal that way if the radio doesn't work. So it should be a fun circuit today, circuit number 6. So let's jump over to the computer and see what we got.
All right, so here we are on the computer. We'll fire up our web browser and we'll go over. Actually, I need to. What am I going to do here? All right, there should be a link here. There it is, project 6 of 30. So this is the transistor and amplification. Complicated electronic circuits are almost always made up of 2 or more simple circuits connected together. This project combines a radio like the one in circuit 4 with a 1 transistor amplifier. Connect the ground and antenna just as you did before and tune in a station. You should get more sound from the earphone this time. While you're listening, let's look at the schematic and see why the sound is louder. In the invisible power radio, the pulses of electricity stirred up by the radio waves were turned into sound by the earphone. In this circuit, those same pulses of electricity are connected to the input of the transistor in the circuit. As the pulses from the input As the pulses turn the input on and off, they create a mirror image of the pulses in the output. Remember that the output is controlled by the input. The pulses from the output are connected to the earphone and are much stronger than the input signal because the batteries are connected to the output of the transistor. Getting a high power signal from a low power signal in this way is called amplification. And here's our circuit. So we've got the coil, the antenna coil here with its various taps. There's a capacitor wired in, and it looks like it doesn't join there. So there's a capacitor over half of the coil, or maybe 2/3 of the coil. There's a diode here which rectifies the amplitude modulation. I'm not sure what the purpose of the capacitor here is, or here for that matter. Okay, that's electrolytic. This is the tuning cap. There's I don't know what you call it when the when you put a capacitor like this on a circuit. So a capacitor will pass AC and block DC, so a signal can get through here. I don't know why the base is tied to 470k. 470k is quite a lot of resistance. I don't know why that's there. And then the base will allow the current to flow through the collector and the emitter. And as they say, the battery is connected to that. And we've got, I don't know what that coil there is. I don't know. I don't understand this bit. Anyway, we'll probably figure it out. So as it says here, this part on the left is the radio, and this part on the right is the amplifier. Actually, we might just do the amplifier in KiCad. We'll see if we can find a suitable symbol for this, but we won't try too hard. And this is the wiring diagram. That's the instructions that I'll be following when I take it over to the booth in a minute. So let's fire up KiCad and see what we can do. Hang on a sec, I'll be back. All right, I'm back. So the last project that we did was the 30in1 project 5. So let's do a new project, and we'll do it in here, and we'll call it Maxitronix 30in1-6. There we go. And we'll open up the schematic. All right. So let's try the let's try that antenna coil first. I really don't know. I don't want to take too much of your time with this. Let's search for coil. Oh dear me. Relay. L coupled ferrite. Oh dear me. There's a billion permutations of these. I have no idea. No idea. Can't search for antenna coil. All right, I think that we're just going to just draw up the amplifier. So let's do that. Let's add cap. Was it C for unpolarized capacitor? It was. Oh no. Oh yep. Okay. So give me a tick. I'll be back. All right, I'm back. So that capacitor is a 0.022 microfarad. All right, so we got to how do we rotate this way? Okay, so we got a cap, and we're going to need an NPN. There it goes, and we're going to need a resistor. There we go. Resistor. Rotate. There we go. All right. Now the piezo. The piezo speaker. How to model that? Give me a second. I'll figure that out again. I'll be back. All right, I'm back. So I I just made some notes over here that we can model the transformer as 2 inductors, and we can model the earphone as a 8 nanofarad cap in series with a 100 ohm resistor. So we can keep on keeping on with the circuit. We'll add Now I don't know if I can just go L for inductor. I can. Great. And what's the button for repeat? It's slash. Yeah, perfect. All right. And the earphone is going to be a cap and a resistor. Very good. Now zoom it all in a bit. That's the one. All right, what are we missing? Nothing. Oh, we're missing power. Okay. So, what are we going to do? Move this over a bit. Oh, no, that's not right. Is that a bit better? Yeah. And then so we're gonna add. I'm not add Q. No, not Q. Add. There we go. And we want VDC. This is we want the spice simulation power. So we'll put that here. All right. And we'll wire that in. All right, are we missing any wires? I don't think we are. So we're just going to set our 0.022 UF. And this is 470K. 470K. And these are 960 millihenries. 960 mH. Okay. All right, now what was this? That was over here. 8 nanofarads. And the voltage was 3 volts. And this resistance was 100 ohms. All right, cool. Well, you know what I might do? Is figure out how I can send in a signal over here um, for the spice simulation. So I'll go and research that, see if I can figure it out. I'll be back soon. All right, I'm back, and I'm happy to report I think I've got it figured out. So, what I did since I left you was I added a thing called a global label. I added one here and called it in, and then I did the same thing here. I've got out. I've labeled that here as well. The details for the simulation of let me just show you again here, V2. When I double click on it, I have the option to model the simulation model. If I click on that, it's a voltage source, and I've got it set up to be a sine wave. By default, it's DC, but you can change it to sine, and when you do, you get these parameters. And I specified the first three parameters as DC offset as 0, so it sits around 0. The amplitude is 5 millivolts, and the frequency is 1 kilohertz. Now, 1 kilohertz is sort of within the audible range, which sort of would be similar to what comes out of a AM radio before or after it's been rectified. So this is just a sine wave just to simulate the antenna. I asked ChatGPT, and it said that that an antenna will output microvolts to maybe a few millivolts. So here I've got 5 millivolts as being the signal. So it's a 1 kilohertz sine wave with a amplitude of 5 millivolts. I don't know if that's RMS or a maximum. It's probably the maximum. We can check that out in the simulation in a second. So I've added this voltage source, and I've added these two labels. And apart from that, it's just the circuit that we built earlier, which is the input of our, it's the output. Yeah, it's the system that receives the signal from the radio. So if we go into the simulator, then it starts new, and then we click here to add a new analysis tab. And the type of analysis we want to do is called a transient analysis. And I made the time step 0.001. I don't think it matters too much. The final time will make it 1 second, and the initial time is 0. So we go OK, and we've added our pins. So we can select V in, and we can select V out. So those are our inputs and outputs that we saw earlier. And then we can play the simulation, and we see down the bottom here, hovering around 0 volts, is our input, and then this blue thing is our output. Now you see the input just sort of flops around. I'm going to use my mouse now to zoom in, so I'm going to zoom right in on the signal there. So that's our sine wave input coming in and just doing its sine wave thing. That's cool. So I'll just zoom out of that, and then we can try and zoom in up here on the actual signal itself. So you can see that that's oscillating quite a lot, going up and down. So this is the signal that's coming out of the earphone, and I don't quite understand why it goes as high as 6 volts. If you understand that, I'd be happy to hear from you. But it just seems to bounce around here between 0 and 6 volts. So I don't know what more to tell you. I think that's kind of what we'd expect from an amplifier, right? Like There's a small input signal. I guess the output signal isn't a sine wave, so that might have something to do with the resolution. I wonder if we could edit the analysis tab. And instead of 1 millisecond, let's make it 1 microsecond. And then run that. Yeah, that's interesting. So with the with doing 1 step per microsecond, the results got a lot closer to the pure sine wave. And I don't know what that looks like. Some weird sort of aliasing, doesn't it? Well, aliasing might not be the right word. Why on earth does it look like that? That's quite odd. And it's an artifact of the resolution of the transient analysis. Let's try that again. And what happens if we make it, what's after micro? Pico? Micro, pico. Let's make it 1 picoseconds. And we'll just do it for 0.1 seconds. And let's run that. Ooh. I wonder how long it's going to make us wait. I might come back when this is done. I'm going to go make coffee while it runs. I'll be back in a sec. All right, I'm back, and I've got myself a fresh coffee, which is very important. And that simulation I was running was trying to count to infinity, so I cancelled it. Let's have a look at the simulator, and I'll show you where I landed. Let's edit this analysis, and you see that we're running a transient analysis, and I've set the time step as 100 nanoseconds, and it'll run for 100 milliseconds. And that seems to give fairly good results. We're plotting V in and V out. So let's run the analysis. And you can see the input is this little wiggle at the bottom, and the output is this big thing here, which jumps up, well, at most nearly 6.4 volts. It seems to settle down a bit too. I'm not sure why that would be. And let me just show you, if we zoom in here a bit, and we don't want to go too far. Yeah, I didn't know why that red line. Oh, we must be. Yeah, okay. How do we just... What I want to show you is that the troughs of this sine wave align with the troughs of the input wave. I wonder, I'll see if it's possible to scale one of the signals. Let me investigate that. I'll be back. All right, I'm back. I haven't been able to find a really good answer. There was a few things that I got suggested to do, but I didn't try them because I just want to move on with this and go to the next thing. But the thing that I did, that I think you can see here, you probably need to be viewing this in 4K, but there's a sine wave down the bottom here, and you can make it out. And I've got this cursor set up so it aligns with the bottom of the sine wave. That's the input signal. And you can see that when I align the signal with the bottom of the input signal, it lines up with the bottom of the output signal too. So we really are seeing here the input signal being amplified. I don't think call this ringing. I don't know. I don't understand why it oscillates quite violently in the beginning and then seems to settle down a fair bit. after it's been running for a millisecond or 100 milliseconds. So yeah, I don't understand why it sort of comes down a bit. Anyway, it's going to be a fun circuit to build because it'll have the radio attached. I'm not expecting that to work, but then we can do what we did here and we can feed in a 1 kilohertz signal from my signal generator, and we should be able to see this in the actual circuit itself. And the oscilloscope will be easier to show you scaled values on that. So we should have two inputs for the oscilloscope when we get around to that part of the circuit. So let's go over to the booth. Let's put this thing together and then we'll get to the bench and we'll test it. All right, well, here we are in the booth. Now the first thing to do is remove the old wires, so let's do that first. All right, well, that's done. So the next thing to do is follow the instructions at the back here and get everything wired up. So let's do that. All right, that's it. It's all wired up. We just need to install the antenna and the earphones, but we can do that on the bench. So let's pop over to the bench and have a look at this thing. All right, well, here we are on the bench. Now, this cable here is my antenna cable, and it's got a shield, so I think that might be ground. I don't know for sure. I think ground for green. What do you reckon? And yellow for the aerial. I also have this mains power earth cable as well. So we've got to attach the antenna, and we've got to attach an earphone, and this is an earphone, so you won't be able to hear it, of course, but I'll test to see if the radio works. I expect it won't. Then we'll turn on the oscilloscope, fire up the signal generator, and send a signal into the amplifier and see if that works. So all right, let me just plug this in. We don't need to go into fast forward for this because it's pretty straightforward. Oh, okay. Give me a second. I'll be back when this is done. I need to get an adapter. Actually, I was wrong. I didn't need an adapter, so that was easy. So it says that one is the antenna. So that's right up the top here. And then on the bottom is ground on 2. Okay. So that's all set up. Now the antenna is going on 20, and is it 18? It is. So we put 18 and 20. All right, now let's have a listen. Okay, I can hear it crackling. It's just crackling. Not picking up anything really interesting. The crackling changes a bit, but it's there's no voices or anything to be heard, no music, just a weird sort of hum. Fair enough. All right, well, we weren't expecting the radio to work, and it doesn't. What happens if I take that off? Well, it makes almost no difference. If I take that off, well, that makes a big difference. Yeah, right, without that, we don't have very much at all. So this is certainly picking up something, but it's just noise. Shall we try the earth cable? We might as well. Just plug this in up the back here. See what happens if we connect that. I can hear voices. This is amazing. It's actually working. hectares of land. Yeah, right. Can you hear that? Definitely human voices. That's amazing. So with the ground lead connected, can you hear it? Sounds like a woman talking about coal or something. Fascinating. Wow, that's great. Wow, I really wasn't expecting that. But we got our radio working. We've got an aerial and a ground, and it works. Shall we go channel hopping? Let's see if we can find another channel. It's only one channel I can pick up. That's it. All right, cool. Well, what I'm going to do is hook up the signal generator to the amplifier, and then get the oscilloscope to have a look at the input signal and the output signal as we had in the simulation. So let's get that set up. I'll be back in a second. Before we hook up the signal generator, I'm just going to take out the wires for the radio and just leave the amplifier wired in. So that's what we're going to do now. All right, so I've got the radio taken out, and the inputs are going to be on the emitter, which is down here, and on the capacitor, which is here. So I'm assuming that line there is correct, and to take out the resistor and the capacitor and all of this part. So we're just going to keep everything on this side. What I might do is just butcher an alligator cable to get the two inputs. So I'll be back in a sec when I've done that. Well, what I was planning to do is cut an alligator cable in half and then use one side for the spring terminal and the other side for the alligator clip. But we don't need to do that. We can just keep these two and just use two of them. So one of the inputs will be on the emitter there, and we'll call that black for negative. And then on the other end of the circuit, we've got the positive input. Now, I'm going to need to get a cable from my signal generator. So let me just go and find a cable. All right, I found a cable. It's BNC to alligator clips. So we can run those in here. And let me just flip you over there. So what are we looking at? Can we get you up there a bit? Okay, that's my signal generator there. So let's see if we can get this working. So channel 1 is in the middle here. So let's just put the BNC cable in. All right, that's it. And then we want to turn it on, power him up. It's Unity. I don't know if you can see that. So what we're going to do is we're going to change the frequency to how do we go this way? Turn that down to 0. No. Is that 1 point? Yeah, that's 1 point. That's 10 kilohertz. That's probably okay. Okay, there we go. Let's get it down to 1 kilohertz is what we were testing with. And the amplitude, what did we have it at? 5 millivolts. So 0.005. Enter. It can't go down that low. Okay, 2 millivolts peak to peak. Okay, cool. Offset 0, phase doesn't matter. Okay, so channel 1 on. Okay, I've got to turn on my oscilloscope here. So that's just, I don't know if you can see over there, the oscilloscope in the background's just booting up. So when that's done, or while it's doing that, let's just pop back over to here. All right. So you can see the signal generators up the back there. It's just set at 2 millivolts peak to peak. And frequency is 1 kilohertz. My Regal has nearly finished booting. It's behind this thing up here. I'm going to have to go in, utility, I/O, HDMI on, and I'll just throw on the old there we go. Up the top there, you can see my my LED star monitor is showing the oscilloscope. Now we're going to need two probes. So I'm just going to put one probe here and the other probe there. So let's hook up channel 1 to the input. Where is ground? I'll call it there. Ground. And let me just wire in. So I'm just going to join up these alligator clips. And then same again for the negative end. This is the signal generator. All right, so that's hooked in. And then we're going to look at, this is, where is channel 1? Channel 1 is here. So channel 1 is going to be the input. So let's put that on there. All right, this is channel 1. And then this is channel 2, and we're going to put it, let's just put it on pin 18 up here. All right, now if I hit auto calibrate and I turn on channel 2, okay, that's on. Okay. Let me see first of all if I can give you, I'll be back in a second. All right, I'm back. So I've got everything showing now up the top here. So on this side, that's the oscilloscope. We've got two inputs that we're testing. This is actually the thermal cam, and it's just there for the ride at the moment. We're not really interested in it. And then this is just the back of the lab up here. You can see the signal generator is here, and there's a duplication of the scope up there. So the first thing I'm going to do is run the signal from number 1 into whatever it is we're getting from the signal generator at the moment. So that should be it, really. That should just be a nice clean wave, but it doesn't look like a nice clean wave, does it? Yeah, that's not a nice clean wave at all. So I'm not sure why it sucks so much. I'm going to turn things off and play around with the settings and see if I can get a better waveform out of my signal generator. All right, I'm back. Now, I don't know what was going on with my signal generator up the back here, but what I've done is I've switched over to using the signal generator from my scope. And you can see here is the sine wave. You can see a nice clean sine wave there in yellow. So that's the input, and that's actually running into here at the moment as the input to our circuit. So that seems to be working pretty well. I'm not sure why the amplitude got so affected there. I don't know. But the blue signal is supposed to be amplifying that yeah. All right, I'm going to play around with my settings. I'll be back in a sec. All right, I'm back. Now, if you have a look at the scope there, it's the sine wave at the top is the input, which is a nice clean sine wave. And then down the bottom is the output, which is a kind of mangled waveform that's gone through our transistor and the and the transformer. But I don't understand, because the channel 1 is 200 millivolts per division and channel 2 is 200 millivolts per division. So it doesn't seem to me that this signal has actually been amplified at all. It looks like there's, basically the same order of magnitude in and out. They're both the same. Yeah, I was expecting to see an amplified signal, but that's not what we see. I don't know what happens if we skip the input capacitor. That input capacitor seems to be important to the signal integrity. That's really quite interesting. If we take it away, then it flatlines. If we hit auto, what do we get? Yeah, wow. So that input capacitor is essential. Interesting. So there we are again with our 200 millivolts per division. I really don't understand. If you understand, please explain to me why the amplifier is not amplifying. We've got it hooked up. It's going through the transistor. It's all wired in. It's all connected up. We put the signal on that side, it comes through. If we put it on that side, it does not come through. Right. So what about if we just put it straight on the transistor? Yeah, still 200 millivolts per division for both of them. So I can't explain that. But I think we'll leave it there. I'll throw over the farewell cam. We'll wrap up.
And that's a wrap. So what did you think of that? I'm surprised that our our KiCad spice simulation seemed to be more veritable than the direct readings on the scope. It was easier to believe what the simulation was telling us versus what the experiment was telling us. So I don't understand why we didn't see any amplification. Maybe it had to do with saturating it. I'll tell you what, let's jump back over to the bench and let's see if we can make the input smaller and if that has any effect. Let's try that just for fun. All right, so what we're going to do is, well, first of all, I need to put the circuit back on. Okay, there it goes. And let's bring up G1 and let's change the amplitude from 500 millivolts. Let's change that to, let's say, 1 millivolt. Oh shit, I didn't mean nano. That's 20 millivolts. All right, so let's amplitude. Let's say 1 millivolt. It seems like 20 millivolts might be the minimum. And let's hit auto again and just see if it can auto tune. Yes. Now we're actually seeing an amplification. So let's just adjust the trigger on that. Where's my trigger? Let's just bring him up there. Up we go. It's jumping around a bit. I don't know why it's doing that. All right. No, that's rubbish. What am I doing wrong? Edge trigger, rising. I don't think we want to change that. What's HFR? That seemed to work pretty well. I don't even know what it means. Do you know what HFR is? Whoops, that's not what I meant to do. All right, so how do we make that go away? Turn the menu off. There we go. And let's just turn that down and bring it up. That's the wrong one. Bring it up. All right. And this one. All right. So that's good. So we figured out the mystery. The problem was that the signal was just way too big for it to be amplified. So when we put the signal down, and we've got it now at 200 millivolts amplitude, I assume that's just on the top side. So perhaps it's 40 millivolts peak to peak. I'm not sure. Is the amplitude just above 0? I think maybe it is. The offset 0. So how do we put the angle on? How about display, grid, brightness, show scale on? There we go. All right. And how do we know? So the scale is on for channel 1. If I press here, will it put the scale on for channel 2? I don't know. 1. All right, and 2. There we go. Okay, so that's from around about 0 to around about 600 millivolts, whereas the input signal is around -10 to +10.
Okay, so that amplitude at 20 was peak to peak. It goes down to -10 and it goes up to 10. Excellent. So now we can say that we've amplified the signal. We've put in 10 millivolts and we've got out 200 millivolts or thereabouts. Call it 100 maybe. So excellent, great, good. Now we'll throw over the farewell cam and we'll wrap up.
All right, now it really is a wrap. I'm glad we did that little extra experiment to turn the signal down, and that accounted for the lack of amplification. Was the input signal was already way too high for it to be amplified. So we turned down the input, and then the output was able to be an amplification of the input. So that's everything. That's the end of the video. I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.